So this video is mostly for page 24, but I already have my graphs for page 23, and I'm just going to graph them to show that we can use the calculator to check. So the first important thing when you're checking this, you want to make sure you set your window to match the window in your graph. So I'm only doing exercise 2, the 4 cosine 3x right now. So my x window is 0 to 2 pi over 3, and my y window is negative 4 to 4. If I want to really see this, I could set my scale to pi over 6 for my x to make that match. So when I look at this graph, I do see that one cycle of cosine, so I know that's correct. For the second one, I am only checking the blue graph. I didn't write an equation for the transformation. I could come up with that thinking what we did last lesson, but I'm just checking my blue graph. So my window here is 0 to 8 pi. My scale is by pi, also again optional, and it looks like my graph goes out up to 2, 4, 6, 8 is the maximum, and the minimum is negative 2. And I could go out a little wider than that, so I messed something up. Just go back to my window, I put those numbers in backwards. So I have negative 2 and 8. Okay, so I see, I'm checking it with the blue graph. Right, the blue graph does look correct, so I know that is correct. So moving on to the next page, our first one, we have another verbal description. We have a cosine function. We need to graph it for 2 cycles. Remember, we always do one first and then just extend it, and we have some qualities for the graph. So we have a midline at y equals negative 2. My period is pi over 2. So I need to get 2 cycles. So I'm going to put pi over 2 here. That means I'm going to have pi for my second cycle, and I'm going to do quarter points to start out. So cosine, we know, starts at the maximum. So if I have a midline of y equals negative 2 and an amplitude of 3, my maximum would be up at 1. Then cosine goes middle, down. So if I'm at negative 2, go down 3, this is going to be at 5. Middle, up. So then from here, we'll put in some more quarter points. So I need middle, down, middle, up. And there is my second period of cosine. Harder to check on my calculator because I don't have an equation. I could write one, but then that's another area where I could make a mistake. So here on the next one, we're going to start to look at a tangent graph, which is kind of its own thing. So we know first off the graph of tangent, and we could graph it, this one's somewhat back to where it was. We could graph it on our calculator, but tangent is that graph that has repeated, like x cubed looking swirls. Okay, that's not great, but we know we have repetition of those. So I also think about transformations here, so I'm just basically graphing tangent and moving it up 3. So tangent, I'm actually going to graph this one on my calculator just to start. So we have tangent x plus 3. I just want to graph it from negative 3 pi over 2 to 3 pi over 2. On my graph, it looks like my scales are going by pi over 2, so I'm going to start with that. So my actual graph goes out to negative 2 pi to 2 pi, but I want to stop at negative 3 pi over 2. So from here, I don't know, I'm going to go negative 5 to 5. Don't really have a lot of information there. So I can see those pieces of tangent moved up 3. I know on my tangent graph, and I can see it here, that the asymptotes, which we know it does have, go at these lines here. And it also looks like I have them out here on the borders. So that, remember, I made my scale go by pi over 2. So this is where those lines are. and I need one, we could call it a piece of tangent in between each one. Now, this is shifted up 3, so I get that point or graph kind of bends differently right there, and from there, really, you can just sketch it in. If you remember, this is like the tangent of 45 goes up, one bigger than where the middle-ish value is. But as long as you draw in, don't touch the lines, bend the graph in the correct direction, that's good enough for algebra 2. Okay, so that is my graph of tangent x plus 3. So on the next one, we have a little bit of a trickier transformation. We have 2 actually. So first off, that negative in the front, we know when we have negative f of x, that's a reflection in the x-axis. So we're expecting our graph to kind of like flip and go in the opposite direction, flip over the x-axis. This right here is a horizontal stretch or compression of 1/2. So we're expecting it to like happen more often and be flipped. So from here, I'm just going to graph it. We're going to look at what window we want. This one is just negative pi over 2 to pi over 2. So change up our function, negative tangent of 2x. We're going to have negative pi over 2 to pi over 2. At this level, I'm not even going to worry about the scale. I'm just going to leave it. Okay, well, once we look at the graph and start to get an idea, we can start to graph it. Okay, so it looks like we see the opposite direction. Okay, it actually looks wider, but that's because I'm looking at such a narrow piece of the graph. So to try to get this translated onto a graph, we're going to have our y-axis centered. It looks like my asymptotes are kind of halfway over to pi over 2. And I can see that makes sense because we're basically smushing the graph. So where my normal asymptotes would be at negative pi over 2, now they're at positive pi over 2. Now they're at positive pi over 4. And my 0 point is now at pi over 2. So I have my 0 points. And I got a 0 point here. I have an asymptote. And if I'm unsure, I don't want to see that, maybe I go to my window and I make my scale go by pi over 4s. And I can see this one kind of here, right? It does look like that is about right. So it's a little bit of calculator, transformations, making those things work together at this level for tangent, because it is a hard graph to do at the algebra 2 level. We do more because of it. So this one goes this way, right? This one goes this way. So to summarize, flipped over the x-axis, definitely looks like that happened. Compressed, right, because those asymptotes are happening more often, and I see those transformations. So the period is basically how long for one cycle of tangent. If I'm going from negative pi over 4 to pi over 4, maybe I think in degrees, that's negative 45 to 45. That's 90 degrees, and that is pi over 2. Because negative pi over 4 to pi over 4, we have 2 quarters going on, that's pi over 2 for the period.